Okay guys, let's look at the periodic table today. First, let's look at what we know. Here's the atomic number. So we know that that gives us the number of protons and the number of electrons, same number, in a neutral atom. And the atomic mass, which gives us the number of protons and the number of, or plus the number of neutrons. Okay. Also, the atomic mass is given to you in a decimal, so be sure that you round it to the nearest whole number. And the symbol, make sure that you only have one capital letter in your symbol. Let's look at groups. So groups are the columns of the periodic table. So they go up and down, which is vertically, but they're numbered across, okay? So the group number gives you the number of valence electrons. And remember, valence electrons are the electrons on the outer shell of the atom, and they tell us the atoms or the elements' reactivity. Since all the elements within a single group have the same number of valence electrons, elements within the same group have the same reactivity. So we skip over the transition metals, and then we're going to go ahead and circle all of the valence electrons for each group, except for helium, which only has 2, even though it's in group 18, and that's because it only has one outer shell. It only has one total energy level. That's because it's on period 1. So periods, the period number tells you the number of energy levels. Okay, so the periods go across, they are the rows. So they go across, but they're numbered up and down, and they give you the number of energy levels, sometimes called the number of rings, the number of orbitals. However it's described, it's the same thing. So let's go ahead and draw a few of these. Put our nucleus on the number and draw your ring. Nucleus on the number, draw your ring, and all the way down. Okay, let's look at some specific groups. So group 1, they are the alkali metals. Okay, they have one valence electron and they're highly reactive. Group 2, they are the alkali earth metals. They have 2 valence electrons and they're also very reactive, just not as much as the alkali metals. Since the alkali metals have 1 valence electron, they really want to react with the halogens, which we'll talk about here in a minute. That's group 17 because they have 7. And so because of the octet rule, they want to get 8. So it's real easy for a 1 and a 7 to combine, to react together to get 8 in that outer shell. Okay, so here are the halogens, group 17. They have 7 valence electrons. They are the most reactive non-metal group. And they want to react with the alkali metals. And then we have our group 18, which are the noble gases. And they are the most stable. And they're the most stable because their outer shell is filled. Their outer energy level is filled. They will not accept any additional electrons. So they are considered stable. Sometimes you'll hear them referred to as inert gases. They are also the only group that is comprised of all gases at room temperature. So noble gases, their outer shell is full. This line separates the metals from the non-metals. So the metals are going to be everything on the left side. And metals share certain characteristics. Most are shiny, malleable, ductile, and good conductors of both heat and electricity. Now, everything to the right of the zigzag line, they are going to be nonmetals. And nonmetals are pretty much opposite of metals as far as their characteristics. Most are dull, brittle, and poor conductors of heat and electricity. Those elements that fall right along the line are called metalloids. and they share properties of both metals and nonmetals. Some of them are what we call semiconductors, which are very important to to our technology industry. They often can conduct electricity well without conducting a lot of heat, so that's very beneficial. Okay, the last thing we need to look at to prepare for our balancing equations tomorrow are chemical formulas. So here we have 4 molecules of carbon dioxide, which means that we have 4 compounds in this chemical formula. Because carbon dioxide has 2 elements, and a compound is anything with 2 separate elements or more. And then when we count the atoms, we have to remember the role of subscripts and coefficients. You have to multiply those in order to get total atoms. So we have 8 atoms of oxygen and 4 of carbon, so we have 12 total atoms. So we're going to be looking at that more tomorrow with our balancing equations. The last thing we need to look at is how this is arranged. So you'll notice that hydrogen has 1 proton, one as the atomic number, and then all the way down here it goes all the way up to atomic number 118. So the periodic table is arranged in order of increasing atomic number. Okay, increasing atomic number. All right, guys, that will do it for our review of the periodic table and get you ready for balancing equations tomorrow.